Simplify x squared minus 2x over x squared minus 4x plus 4. Rational expressions are just like fractions, but they're more complicated versions of fractions because they have variables and exponents in the numerator and denominator. Just like numerical fractions, we're going to want to reduce rational expressions. And to motivate this a little bit, I want to reduce a numerical fraction. So let's take a look at 4/6. All right, we know that 4/6 reduces to 2/3. And the reason is because the top and bottom are both divisible by 2. So 4 divided by 2 gives us the 2, and 6 divided by 2 gives us the 3. We know that we're allowed to divide the top and bottom of a fraction by the same number. There's another way to look at this. If we take 4/6 and we factor the numerator and denominator, 4 is 2 times 2, and 6 is 2 times 3. And both the top and bottom have 2 as a factor, so we can cancel out one factor of 2 in the top and 1 in the bottom, and that leaves us with 2/3. It's important here to note that the things that we're canceling are factors. We can cancel a factor that the top and bottom have in common because we are technically dividing the top and bottom by that factor. Let's go back to our problem. Simplify x squared minus 2x over x squared minus 4x plus 4. If we want to reduce this like we reduced 4/6, we need to factor it first so that we can see if there are any common factors in the top and bottom. Let's look at the numerator, x squared minus 2x. Those two terms have a greatest common factor of x, so we can factor that by pulling out the x, and that leaves us with leftovers, x minus 2. In the denominator, x squared minus 4x plus 4 is a trinomial. We can use the unfoiling method here. We need two numbers that have a product of 4 and a sum of -4, and those numbers are -2 and -2. So the denominator factors into x minus 2 times x minus 2. Now, if we look at the top and bottom to see if there are any factors in common, we notice that both the top and bottom have x minus 2 as a factor, so we can cancel those factors out. Just like in the numerical fraction, when there was a factor in the top and bottom that was the same, we could cancel it out because we were effectively dividing the top and bottom by that factor. Here we can cancel out the x minus 2's because we're effectively dividing the top and bottom by x minus 2. When we do that, we're left with x in the numerator and x minus 2 in the denominator, and this ends up being our final answer. I'm going to address one of the most common mistakes that students make here at this point. We have x over x minus 2. Occasionally, I have students who want to cancel out the x's in the top and bottom. But we can't do that because the x in the bottom isn't a factor. X in the bottom isn't being multiplied by anything. In fact, what's happening to that x is 2 is being subtracted from it. So if we got rid of this x, if we started with x minus 2 and we wanted to end up with -2, we'd have to subtract the x to get rid of it. But we're not allowed to subtract the same quantity from the top and bottom of a fraction. We can only divide the top and bottom by the same quantity. So in a situation like this, the x's aren't going to go away. The same thing is true in the original problem. If you look at the x squared in the top and the x squared in the bottom, if we wanted to just get rid of them, we'd actually need to subtract them away. To take x squared minus 2x and get rid of that x squared, if we eliminate a term like that, we need to subtract it away. But again, we are not allowed to subtract the same quantity from the top and bottom of a fraction. We can only divide the same thing from the top and bottom. So in a situation like this, when we are simplifying, the rule is that first we have to factor anything that can be factored, and then second, we can cancel any common factors. between the numerator and the denominator. You have to factor before you can cancel. Otherwise, you're just not doing it right.